Okay, I'd like to take a look at this problem. This is an application of some of the stuff we did, but it is a little bit more involved than what we saw previously. So it says, suppose certain coin weights are normally distributed with a mean of 5.126 and a standard deviation of 0.073. A vending machine is configured to accept those coins with weights between 5.016 and 5.236. So what does that mean? We have a standard normal distribution like this, right? And anything that's above 5.016 and also below a value of 5.236, those ones are going to be accepted and all the other ones are going to be rejected. So it says if 290 coins are inserted into a vending machine, what is the expected number of rejected coins? What we want to do is we're going to try to find what percent is down here, what percent is down here. So we get a total percentage that is going to be rejected, and then we're going to multiply that by 290. So first, let's go ahead and find that area to the left. And this is not the fanciest video, but I wanted to get something to you today. So I'm going to be calculating the area to the left. So this value down here is 5.016. All right, and then so we're going to do normal CDF, right? So we're going to hit second, vars, go down to normal CDF. Our lower value for this first one, since we've shaded out that way forever, it's going to be negative 10,000 or negative 1,000. I'm going to use 10,000 here. My upper value is 5.016. And then what's our mean and standard deviation? Those are going to come from our original problem. Our mean is 5.126. Whoops. So our mean is 5.126, and our standard deviation is 0.073. And when we run that number, we find that that area to the left is 0.0659, or 6.59%. So 0.0659. Again, sorry for having to write in paint, but it's better than nothing. Okay. Now we're going to do the same thing for this area to the left. Remember that this value is 5.236, so 5.236. So we're going to do a normal CDF with this. This is 5.236 to 10,000, so we're going to do normal CDF. Our lower is 5.236. Our upper is 10,000. Same mean and standard deviation, right? And when we run that one, we get the same. So 0.06592. All right. So what's this total area? So to get our total area, we are going to add those two together. So it's going to be 0.06592 plus 0.06592. So that means about 13.184. So 13% of our coins will be rejected. How many coins are we putting in this machine? We're putting 290, so we multiply our final answer by 290. So that on average, we can expect to reject about 38 of the 290 coins. If 290 coins are inserted into a vending machine, what is the probability that the mean falls between the limits 0.0516 and 5.236? So this next problem, we are now going to, if 290 different coins are inserted into the vending machine, what's the probability that the mean falls between these two values? Here's where we're going to use sampling distribution. So when I take a look at the chapter 6.5 notes, you can see that the mean is going to remain the same, but our standard deviation is now going to be the old square root divided by the old standard deviation divided by the square root of the number that I'm going to sample. So my new square root is going to be, what's the old one? 0.073 divided by the square root of, we're entering in, we are trying 290 coins, right? And so I get 0.0043. So now we're going to do a normal CDF. Our lower value is going to be 5.016. Our upper value is going to be 5.236. Our mean is still going to remain the same. And then our standard deviation is 0.0043, because that's what we just computed. And I get a probability of 1. So the probability that the mean falls between that is 1. Finally, which result is more important to the owner of the vending machine? I don't really care about the average, but because coins could be rejected, that means sales would be lost, right? So that's why we would use part A, because we actually found how many coins would end up rejected if you put 290 in there.